Excellent. So first things first, thanks for coming. It is a bit late on day 2 of a long but fun conference, so it's always nice to see a full crowd. Anyone who can't stay for the whole thing, don't worry. These are recorded. The slides will be online, and if you want to reach out afterwards and have a chat, just do so. Always happy to talk through anything I discuss here today. So without further ado, let's talk about making real-time decisions with data. And first of all, anyone who's seen any of my presentations before, these come with a pun warning. I will make bad jokes, and I will grin when you groan, and I will enjoy it, and I will tell you you were warned. So, that aside, a bit about who I am. So these days, I kind of work as a bit of an open source technology sommelier. I'm here to pair your Kafka, your ETL tools, your Postgres, maybe your Snowflake, and maybe some cheese to go with that, trying to give you that full, holistic picture of what is possible. Most of what I do is to try and show people the art of the possible with both open source and other tools to kind of help you build out the bigger picture of what you can really do with data. I've worked on a bit of everything from MMO games like Sea of Thieves and EVE Online to literal point-of-care medical diagnostics in the past. I even started a Google Glass company, and you can search it online and find the video we made 10 years ago when it was the coolest thing. And yes, it did not do well. And these days, I code in Rust for more crustacean jokes. Because who here, hands up quickly, who's heard of AIVEN where I work? So it is a Finnish company, hence AIVEN, not AVEN. But hands up. The 2 people who probably know who I am already. Cool. So this, who knows what this is, by the way? So this is the Crab Nebula. This is one of the most pretty nebulas in the sky. This is a picture from Hubble. Hopefully there'll be a better one from the James Webb Telescope next. And this is Rapu, who's our little crab logo, and 7 of his 11 favorite open source friends. AIVEN is a data platform for hosting open source technologies with one API, one SLA, one developer experience, and one bill for all of your data needs. We bring the open source to you so you can use it across any cloud you like. And the stars are the limits with open source data tools, because the Crab Nebula with the crab inside it must be a pretty bad joke for somebody. So, a bit more about this, because inevitably, marketing tell me I have to talk about what we actually do. So we store, stream, and analyze your data for you across all the major clouds. We go inside your cloud if you need you to. We integrate with almost everything you're probably already using, and most of the people around here. We run Kafka, Flink, Cassandra, Postgres at crazy scale. And we do it for all kinds of fun people. Most importantly, which ones I enjoy talking about are, of course, the UK government, because where we are now. Sneak, because they're nice and secure and everyone forgets that we actually power bits to them. Blizzard, because I'm an avid gamer. And Toyota, because their recent Kafka stuff has nothing to do with us. That stuff didn't crash. That was an on-prem deployment. So, quick clarification of terms. What I mean by real-time. So real-time I'm talking about here is soft real-time. So I'm just going to say real-time and mean soft real-time. And by this, I mean data as fast as possible on commercial off-the-shelf software and commercial off-the-shelf hardware. We're not dealing with watchdog timers on safety-critical systems here, because that's not the game of any of these pieces of software. And ChatGPT, which we all know and kind of have to deal with, which is, of course, the scariest piece of software out there. I used to build milsims and military hardware, and this is still scarier from what it can do. But it's not really the subject of this talk. This is not another AI talk, don't worry. I'll reference it here and there, because sadly the reality of the business these days is it is very powerful and is a tool you use. However, it is not the be-all or end-all of anything. So let's talk about what needs to be real-time. Real-time comes about when you need to make a decision quickly, whether it's a dating app, whether it's a game kind of thing. Let's say you want to find the right people to have a game with. Whether you're making a trade on your phone app, and you're going to say, I actually have to sell these options now so I can afford my car payments. Or, you're going to recommend a movie. There's actually a very tight time window on when that next recommendation comes in, and it has to be made from a lot of real-time data on what you just watched, what you watched last week, what people in your cohort are watching, and what's hot in the country you're in right now. Without this kind of information, you can make some really bad decisions. And then, of course, the classic stuff is kind of equity trading on Bloomberg terminals. This stuff's always needed to be fast, to the point of where they actually straightened a fiber run between 2 cities to try and give an edge on this kind of deal. So let's take a scenario. You're on the phone, you want to recommend an action movie, suitable for 5-year-olds, lots of animals, so Despicable Me is out. You want to make a trade, GameStop for Bitcoin, or get a taxi from Hogwarts to Narnia with 5 people and a dragon. Each of these things requires different data to solve, different requirements to match, and multiple different APIs to call. And it starts to get quite complicated when you start to try and make these decisions in real time, like, can I book this taxi? Can I accept this load? Am I going in the right direction? Can I actually make that trade? Do I have enough liquidity? Am I going to go farther than my margin edges? Also, on the other one, it's simply that, is this movie appropriate? Is it able to stream it in this country? Is it about to go out of service? These things all matter. And the window of success is what terms real time. So if you're recommending a movie, you really only have about a second before people browse off that part of your website. In a trade, these are often user-defined. Option contracts can last a long time. However, there are also very hard boundaries on what they're allowed to be. And for a taxi, I don't know how many of you will wait for more than about 10 minutes before they switch ride-sharing service and then bounce to the next one and the next one. But I found about 10 minutes is about the limit I've ever been able to wait for any of these services. And what really makes it real is that cost of failure. You churn a user when you don't give them the right thing to watch next. They will leave the service they're on. This is important because that is what makes you money, is keeping people engaged for longer periods of time. Same thing with trades. Either you should not make the trade, or you'll probably expose yourself to near unlimited liability of selling a post-dated option. And taxi rides are even worse because I use whatever app is the most recent one I've used. So if I churn off one app to the next one, I'm using it until I churn off that one. So that customer is not going to stick. This goes doubly for API products, that if you can't reliably get the data you need or build the dashboard you want fast enough, you're going to make a bad decision. And that's kind of unacceptable. So let's talk about why it's hard. So the first problem is, of course, users waiting. We kind of reference this in what actually things cost when they don't work. And let's take that fun example. You're away from home, maybe at a conference. It's raining, like it was yesterday. You want to summon a ride. You want to order food on a complicated app which has millions of buttons all over it. You want to change your flight. Hands up here who's had a bad experience changing a flight. About half the audience. Hands up here who's had a good one. No one. That's what I expected. And it gets worse the deeper you try and do it inside anything smaller than, a screen that a Bloomberg terminal would feel jealous about. You need as many options as possible, and it will change in real time. The prices will change on you. Or arrange a venue for an event. This is my own personal hell as I run meetups in London. And trying to find a venue which can cope with the numbers you might expect is really hard. But anything with an app ends up with the same problem. Anything with, whether it's a graphical interface, whether it's your Sisense dashboard, your Superbet set dashboard, or anything else. Anytime you build an app to do something, which has to be real time, you end up making decisions against data that may or may not be stale, may or may not require other APIs to call, and may or may not return a decision you don't like. Because what you really wanted was this, a guided experience that got you what you wanted, either the answer, the result, or the trade, or equivalent. I think they're calling for prizes, so no worries. But what you ended up getting was something like this, a million bells and whistles. Have you ever seen behind what's on in Superset when you have to go and tweak the settings? Or you have to go reconfigure the query that drives something live to try and make it a bit faster? Or you actually start digging into flight changing apps? You end up with this massive dashboard of tools, which is it's not what you really wanted. It makes you feel a bit like this. Things are going on, you press buttons, you hope you get results. And this goes doubly for API products. When you call an API, you hope it returns. Occasionally you poll it. You hope it's idempotent. You hope it doesn't trash your servers because it's now going to return 8 things rather than 1. And it sucks because of speed is money. You can only make valuable decisions if you have the data in front of you. Whether it's a buying decision that you see it's worth buying more ads for your current product, whether it's a trade decision of saying this is the right thing, or that's the right ride, I want to make it now. Because idle resources are pointless. Happy users keep using the system, and upfront time needs to be minimized. There's a reason we pay for pre-aggregation. It's because we want to get results now when we need them, not fire something off and come back tomorrow, whether it's an API request or a dashboard. And we can do better, because bad UX really wastes time. And often a bad experience is worse than no experience. If they simply said, no rides available, rather than waiting you 20 minutes before they tell you no rides are available, you'd probably be better off with it. You wouldn't actually be angry, because confusion and breaching of the social contract is a huge issue. And it doesn't matter if it's a developer trying to use an API, you trying to book a taxi, you trying to get some data out of a dashboard. It doesn't matter. If the thing is failing you and you've paid for it, it's going to make you upset. And most of the time that leads to churn or just continually bad decisions being made. So to make decisions, I'll do this stuff, you have to go faster. So that's the why. Let's talk about the how. So what do we need to do this? Nearly always you want historic data. You want trends and past information. You probably want some live data to say what's going on right now, the status of you, where you are, what your current user experience is. If you're doing a customer data platform, you want to know where the user is in their journey, what they've got in their basket. And then you need a bunch of math, because you're inevitably going to have some demand curve, maybe you got some AI, or so much more, particularly in the case of AI. And so now we're going to think about the technology. So first things first is we're going to connect a lot of things, because inevitably these are various microservices all working together in concert. So we'll need a place to work on that data, and something to plug it all together. So let's talk about PubSub, and I don't mean nautical drinking establishments. Yes, you were warned, and you were warned about that too. So there are many options, and as you've seen from around here, like Kafka is currently the winning one. RabbitMQ is a wonderful example of going above version 1 is not necessary for success. Nats has sort of gone down by the wayside, but with new people like Memphis, it's started to resurge a bit. And MQTT is the new IBM from the 90s is still the right answer thing, as it still runs most things in the IoT world. So let's talk a bit about Kafka. Kafka has a lot of things it can do. One of its big advantages is the ability to turn a stream into a batch into a stream into a stream, and a batch into a batch. Throw what you like in at one end and take it out the other in whatever kind of usage pattern you need. It's kind of super powerful. But the big thing here is stream processing. Because it's a durable store which is immutable, it's very easy to pull streams of event off it and then do work upon those without interrupting other people, other microservices. And you can talk to it in almost any way, from Kafka, from Java to Python to various things like WebSockets or GraphQL. There are various ways to plug on the end of it. It also talks to most of your databases, meaning it ends up being either all-purpose blast resilience or glue between microservices and databases. The basics of stream processing here are quite straightforward. You put things in Kafka, you then put you either filter them out, you map them across various processes, you collect the results, and you stream them out to something that matters. This case is just a WebSocket for a demonstration. So what we end up, let's say, doing is we gather our data, we sort it out, we do some magic LML in the middle for the sake of argument, and we want to transmit it over the wire. But this requires so much data. Just building up any of these models or any of these kind of predictions is hard. And it gets complicated, because the responses are limited when you end up with these kind of data solutions, which you have to train yourself. You often know what you know, but you don't have the tooling to build the stuff around it. So we cheat. And this is where ChatGPT will come a brief appearance in this talk, because what it can do is translate the human into the machine and the machine into the human. Literally nothing else. It doesn't actually think for itself. It doesn't make decisions for you. But what it will do is allow you to build decision logic on top of human speech, on top of human inference, and then explain things back to you when you give it the right numbers and the right prompts. You still got to do a lot of training to make it your own, but it does have some real ability to it. But the key thing to understand is it's not magic, but it is a great way to cheat. So let's put it together. We're going to start with some user state, which changes rapidly. So we'll use some Cassandra. We'll stream it into Kafka. We're going to use quick streams rather than Kafka streams. Great friends of mine, they run a booth somewhere over there. I love giving them a shout out about this because it's a Python native way to do all this stuff. We're going to put historic data and the kind of long-term memory and vector search inside ClickHouse, which is an open source data warehouse. And then we're going to do some calculations. We're going to use some inference to say this is what someone wanted, stream their user state, come up with a decision, save it somewhere, send it over the wire to them. And this gets really powerful because we can do this per user. And we can do it per user with both transactions and analytics in under 10 milliseconds. Because when you start cascading these decisions down your stack, you have to be fast in every time. Otherwise, your actual time to a response starts to kick out. Everyone's saying, it's 100 milliseconds for a big query. That's great. Until it's 100 milliseconds for 6 queries in a row before you get a response. Add on some API lag and the rest of it, and it's a 3-second wait for the click of a button. That's not really acceptable anymore. And particularly if you're chatting with something which is supposed to be live, you don't want that. Hence, we use really, really fast tools everywhere we can, and ideally open source. But now let's add some more steps, because inevitably we're not just trying to do a chatbot here. We're actually trying to make something which can do the business logic behind the chatbot. So now we've got to trigger something off. We're going to scatter out a series of commands. We're going to transact across multiple databases, and we're going to have to gather this back and somehow deal with an asynchronous transactional state, which can fail across any part of this distributed system we've built. Multi-step decisions, how do we know it's finished? Hands up here who's built a system that has to poll numerous times to check if the parts are complete. Couple there, yeah, there's a few very kind of grumpy-looking software engineers who've had to build systems where there's like 10 parts of the system running, there may be a direct acyclical graph of processing, no one knows when it's going to finish, or that kind of map-reduce job which is slowly ticking away and you're waiting for that last bit to finish before you check if it's real or not. But what comes to this is a pattern called completion criteria. completion criteria effectively is a way to do a checklist of saying, I have this job. It requires these 10 parts to complete. So what I'm going to do is make a completion criteria when I submit the job to say, on these 12 or so pieces, I'm going to wait till they're all finished before I know what's happening. The advantage here is we can actually do a join on that stream. We can say, this is the thing we want to do. We want to join on a search complete, a thing delivered onto our warehouse, a dispatch note sent to our driver, and a payment gateway completing. We can now join on all 4 of those events on a stream and say, only emit the complete state when it finishes. Better than that, we can time window it. In most streaming joining solutions, you have the ability to say, this is a 30-second window for this join to happen, at which point we can then emit a rollback state of, this is now a failed event. Undo what we just did, because otherwise we're going to have disparate state in different places, and those wonderful places where you paid for something, but it didn't come through, or the delivery didn't happen, and you end up on support going, hey, what happened? And they're going, well, got to quickly manually alter a database behind the scenes quickly. The number of times I've worked with people and found that their support people mostly just have raw database access and the ability to unwind commands behind the scenes for orders, for logistics solutions, for trading solutions. It's kind of scary when you see the fact that you now just have people hacking away at databases because of rollback across multiple systems is not something you would easily do unless you design up front for it. Because here's the thing, streaming joins are transactional. So you can have a transaction that says, this is a complete join, and then say, oh no, it's finished, the transaction failed, and then unroll all the steps. But the question then, of course, is how to do it. Hands up here who's heard of Apache Flink? About 2/3 of the audience. So, Apache Flink is another open source thing in the Apache Foundation. It's about the same age as Apache Spark, maybe a few months older. But it came from the kind of real-time version of things rather than the big data grid style of things. It's a robust streaming platform for both batch and stream processing, run by many people at kind of crazy scale. Like Alibaba use this to handle their orders on the kind of couples day rush. So that is an event about 8 times bigger than Black Friday in America, of the whole of America on one website. It's that kind of scale, and you can just scale it up to make this happen. It also supports SQL and loads of other cool stuff, meaning you can do this kind of live streaming data enrichment along with having to do this kind of crunchy workload management along the way. So let's talk about completion criteria. Similar diagram. Let's say you submit this thing out, your chatbot, you say, let's do something, let's order some goods. So user state changes, so you submit a user state change, you submit a thing to say, send me a shipment. You want to look up historic data to make sure that we know where they live, we know we're going to send them the right thing, we're not going to overbuild them. Cool. So we wait till all those transactions go out. We then have a running join in Flink that says, wait for the prime window, and when it completes, we save it to disk and know it happens. Because through Kafka, we can put it anywhere we want. And the best thing is, this stuff just tiers out. You can have any number of these distributed transactions running at almost any scale. You can have a distributed transaction scale another distributed transaction. And you can just have completion criteria. And using something called the routing slip pattern, anytime you want to unwind any of these, you can just cascade back through each of the steps they went through to get it all done. And this is where it gets fun, because what we've now established is we can chain events together with transactions across things. But we can actually go further and say, let's extract some data. Let's say an event from a database, a bit of CDC. And we go, let's enhance it. Let's actually do some work. Maybe it's a bit of inference. Maybe it's just some hardcore crunching to try and root it down, compress that data down. Or it's a SQL command written by an analyst who knows what they want, but they want that kind of streaming output. Then we're going to load it through Kafka standard into one of these kind of big analytics tools like Opensearch or ClickHouse. But then we want to optimize it. So this is why, like downstream, you want to make sure your database can optimize on top of it. The reason we do transformations in flight is because we can amortize the cost of a small node over a long period of time, rather than having to do big lifts and shifts and kind of talk up those huge S3 bills we keep seeing whenever we do a transformation. Why not just denormalize in memory while it's there? So, without further ado, who would like to see a little bit of this in action? This is a simulated data type pipeline I built. So this is open source. Ask me afterwards. I'll send you the data generator. It's on my GitHub. And what we're doing here is simulating basket IDs coming through on e-commerce. We're using Flink to do some denormalization. And then inside and out of Apache Kafka, we're going to throw it in Opensearch to allow for some dashboarding. Opensearch is kind of a fork of Elasticsearch with Kibana brought along with it. And we're also going to then throw it into ClickHouse for big analytics. We're not going to show ClickHouse because it doesn't come with native graphs, and we love a pretty graph. So this is an analytics dashboard with Opensearch. And this is just simulating a fake shop I built, shopping chain I designed in America, which I call CrabMart. It has 10 locations in the biggest cities, and over there we're running a series of holiday promotions, and we're seeing which purchases were influenced by holiday buys. And we have the ability to, in real time, create these dashboards that update every few seconds to see if marketing campaigns are working, see total analytics of like sum up, roll ups of what's happening. We can even do fun things like you can in Kibana and say, let's do alerts, let's do logs, let's do compressions, and have all the kind of usual patterns you'd expect. Yes, I'm a big fan of Opensearch. And the key thing here is that these are open tools which just allow you to bolt on to what you've already got. At no point have we lost the speed of our transactional workload. At no point have we undone anything which is upstream of this. And because we have that ability to unwind that transaction, we can even remove that data downstream with no risk if we need to. I have a full demo of this, but it's a bit more boring and very corporate. So if you want to hear about that and how to handle out-of-stock purchases for e-commerce buys, I will happily talk to you about it later. So instead, let's jump back to this. So the other option here, of course, is now we've got this real-time state and stuff, is we can make games. So Kafka is great for moving events around. Cassandra, which is our little Cassandra logo. We have the kangaroo for Kafka because apparently our branding team really, really wanted to make it confusing. But we can store distributed state in Cassandra, have Kafka as their event brokers, and use things like WebRTC out of like Python workers to commit games. And this lets you go at crazy speed at crazy scale. Would you like to try it? So if you scan the QR code now, you will enter a game called Crab, Paper, Scissors. It is set up for a previous event, and I never get any time to fix things, so I apologize. If you get past the top score screen, you will eventually get to a call to action for Google Next in San Francisco 3 weeks ago. But hey, we never get time to finish things. So the core of this game is it'll take about 30 seconds to connect because WebRTC will be slow right now because of the number of people connecting. But then you'll all be able to play together in the same rock, paper, scissors world. The only thing you'll get by entering your email address is me sending you a copy of the source code. This does not go to a marketing database because they don't know how to use Cassandra. So if you want the source code of the game, please make sure you enter the right email address. The link is live for the next 2 weeks, so please share and have fun. It works much better on Wi-Fi, which you own. And if you want to try AIVEN, AIVEN, as I said, is a data platform. This will give you a few hundred credits to play with. All of the 11 tools are there, any cloud you like. Either just roll it yourself. If you use this one, you won't be chased because it comes from a DevRel account, which means it doesn't actually get triggered on a marketing campaign. So the whole thing here is that like everything I've talked about today is open source. It works with any piece of stack. It will work with Confluent. It will work with Snowflake. It will work with Stream. Hell, I've got demos with Confluent on their website. They're really cool. So the whole idea here is to show you what is the art of the possible when you start chaining these open source pieces together. Because as you start to get out to make real-time decisions, you need to be able to have this transactional state at scale. And the best thing about these kind of routing slips and completion criteria is these are just design patterns. You can use this in a single node. You can use this across the distributed system. There's no kind of like tie down to saying you must use AIVEN. No, go roll it on someone else's Flink. It's great. Dakota will have an awesome product. And that's what I'm trying to get across here. And thank you for listening. This is just my link to my LinkedIn, so if you want to reach out to me, please add me. Happy to talk anything about data architecture.